Welcome back to Python for Data Fundamentals. You're in Unit 2, so that means you finished Unit 1, so congratulations. And maybe this is actually your second time around in the loop of the class, or third or fourth, so even better. Just as a reminder, the best way to do this class, or to get the most out of it, is to definitely pause and work through this as you're going through the class, and to do the exercises, and then to also apply it to a project that you're working on, or the project that I've given you in the class. So with that, we'll jump right into it. X equals 1. This over here is your identifier, which is a type of variable. So 6 of one, half dozen of the other. Over here, this is going to be your variable that loads into it. This also becomes an object. So we're going to talk a little bit more about identifiers and objects. We're going to get into basic math modules, a little bit of Boolean. I take a look at if, then, else, and else if, and how you do it in Python. And we'll be taking a look at the project exercise. Also, as a reminder, this is just kind of a demo run through. So just remember to pause and try some of the exercises out. And here we go. There are some rules for identifiers. You can't start with a number, so you can't have something like 03 test. You don't want any blanks in between it. Can't have any symbols. And it is case sensitive, so a lowercase x is not the same as an uppercase x. And remember, this is, you're giving an identifier to a variable, or it's just some kind of logic that you have where you're loading it into that object so that you could call it later. And so you want to make sure that what you're naming it makes sense. You want to avoid underscores. And double underscores are actually kind of reserved for built-in use cases. These are some of the reserved words that you cannot use for when you're creating your objects. There are some style guidelines. You know, I've been using like X and Y and Z just for speed. You're probably going to want to put something a little bit more in there that tells somebody, hey, this is what's actually what this represents. And I kind of go through this. You can read through it, but essentially something like this is a little bit cryptic. And something like this is pretty long. So something in the middle is actually probably you're going to want to go for something maybe along this lines for your total sales revenue for Q1. The reason why you don't want to spell it out too much is you're going to see that you're going to have a novel on your hands if you're not careful. So again, not too cryptic, not overly wordy, somewhere in the middle. This might even be a little, SLS might work, and you can see I'm breaking a rule here with an underscore, but that's just for readability. So even though it's a good idea not to use them, it's probably more at the beginning than at the end. Okay, so with objects, they have properties. So like, for example, the property could have a value of 20, or the string that's being loaded into it. It has a type, which we've seen before, which is an integer or a string, and it actually has an identity. So when you actually take a look at properties, you'll see it come out like the value is 20, the type is integer, and the identifier, and then this is the unique identifier. So if we want to run this, we can say 2 plus 2 and put this into X and put A, B, C into Y. So we'll go ahead and run this. And then if we want to take a look at the type of X, we can see that X type is a class integer. If we want to run this one here, we can see that the ID sequence is this, which can be helpful when you're doing a little bit of troubleshooting. To be honest, I've never needed to use this, but in some extreme cases, you may need to get in and start looking around at the sequences. And you can run both these at the same time. There you go. You can actually load in multiple objects with a bunch of values. So we have these multiple objects here. We have multiple values. One's going to go into X, 2 is going to go into Y, and 3 is going to go into Z. So far, you've just seen me load one value into an object. Now I'm going to load multiple values into an object. So I'll run this whole business down here so you can see it work. So we can see that one loaded into X, and here I'm printing out all 3, and here I'm actually doing some math with it. This is one of these things that's really easy to see and go, yeah, I got it, move on, and then totally forget about it. All right, so basic math. When you're getting into basic math, we won't go into a whole bunch of math because this is a Python class, but it's just PEMDAS, and you want to give some nice spaces in between, your parentheses. And so we're going to get into basic math, and you want to make sure to make it readable by using spaces. So you can see here's addition, subtraction. Here's how you can do power of using 2 splat symbols or a star. The modulus you can use, and here we have a division which will end with a float, and a double division will end with an integer. So we can run these to see how it looks. You know, I'm really happy to see that Python 3 has fixed this. So it used to be back in the day that you would go in and you would see like 10 divided by 3. And if we ran this, you get 3.333333333. Back in Python 2, you would not get the decimal point. But the way around it is to just say, I remember going into Stack Overflow, just a page of code to get your decimal point in there when you're trying to do this. Or you just put that and then it would work. So I'm always a big fan of this. There's always going to be an extremely overly complicated way to do something and a simple way to do it. All right, moving down here. Order of operations. This is all going to be the same. When you're working with your order of operations, the biggest thing is parentheses start to go a little bit crazy. And that's your typical error that you run into. So most of us know how to find the area of a room. Length times width equals the area. So go ahead and create using identifiers and using math, a little bit of a formula here that will print out the area of a room. You could even use inputs, do a little refresher from the first unit. And that way you can actually say, okay, this is my area. Just create a little length width area calculator. You can pause right now and do that. Next up, we have what kind of formulas you use at work. This is a good time to just pause and just think about a couple formulas that you might use. Could be a project that you're currently working on. How would you make a calculator out of it right now? What's the formula? And just see if you can get it to work with a basic input that you can type into the screen. But when you have those inputs, you're going to have to convert it to an integer because it always takes it as a string. Rounding, this always is something that you want to be checking out, especially when you're going between SQL, Python, Excel, Tableau, how it's going to round things. So I like to just build a little test like this and see, you know, okay, how is it going to behave and how's it going to round up or round down. So you can use different numbers in here to see how that round up, round down will be. I probably shouldn't put 3 into 10. I think it was thinking about that old issue. All right, so this section here, what we're going to do is take this statement and actually compress it. So if you read it, we're taking 10, loading this into x, and then we're saying x, which is 10, plus 5 is going to be loaded into this object of x here, and then we're going to print it out. So if we print this, there we go with 15. How we compress this is we're just taking this statement right here, and we're getting rid of this x, so just get rid of it, and we're going to remove this there and put that equals over there. So this is going to be x plus its previous self. So x plus, it's going to equal into this x. This is a compression for math, and while it at first doesn't seem as readable or kind of flies in the face of it, after a while you get really used to it and you can see how it speeds things up for reading. So it works out there like that. All right, here's an example of each of these for division, multiplication, subtraction, so on and so forth. So here's an exercise for you. What I'm asking you to do here is to build an equation that you use at home or at work. Could be something simple, you know, a budget type calculator thing. Use rounding to bring back various precision. And look for opportunities, you know, add a little bit to this where you look for an opportunity to use one of these compression type assignments. Down here, you know, if you don't come up with a opportunity, that's fine. Here, I'm giving you a chance to practice compressing this down. One of the ways that you can do this is look up here, and of course, like scroll down and try it without being able to see it. So go ahead and pause the video and try this now. All right, next we're going to be taking a look at the math module. This is all built in for you. There was people out there that just really wanted to help you out and they did a lot of math work for you. So all you have to do is call the code, import it, bring it in, and use it. So we can import the entire module, the entire everything that's in math right here just by running this statement. Everything will come in. Seems like a great idea until you're doing a pretty massive program and you're importing a lot of libraries and it starts to slow things down because it's going to want to compile all of that. Here, what I'm going to do is I'm going to say from math, I actually just want to import square root. So I can do this and this will bring in the square root function that I can then use. So here's square root, so I'm going to print I've got the function square root where I'm passing an argument of 4, and it should print this out. There's other math functions. There's ceiling, there's floor. If I try to do these right now, won't work. You're like, but you imported math. It's like, yep, but I kind of went over the top of that and said, hey, this is actually what I'm going to do. So it's not defined. What I could do is I can go down here and I could actually put in 2 functions at one time. So I can say, hey, I want to go into math and I want to bring in 2 functions at one time, and that will work just fine. Still nothing to do with floor. So if I import the entire math module, all these will run. You might be wondering, well, how do I know what's in the math module? You can do this with any of these. You can type in help math, and we can run this. This gives us a lot of what is in math. You could also go to python.org and see a lot of these things, but it shows you what is available in math. Okay, down here we have a savings calculator using the power of function, which is going to give us the power of a value that we put in. So we're importing math. We'll just import all of it for this one. And we're going to be entering in what our initial savings is. We're going to change this to a float and load this into the base. Then we're going to be entering in the annual interest rate. That is a float, and enter that into rate. Doing the same thing for years. And then we have a calculation that we're actually running. So we're using math here with one of the functions. Notice, you know, I didn't really break it down up here, but you have your module, your library here. You have a period, and then you have the function that you're calling and the arguments that you're passing into the function. So here I've got power of 1 plus the rate divided by 100, the years in here. So if we run this whole thing, actually we want to run it down here, because what this is doing is it's saying, let's take the years, we're going to print this out, we're going to take the total, which takes this calculation and puts it in here so we can run this. And this is just giving you an example. Obviously you can build something a little bit more fancy. Enter initial savings, let's put $100. Give ourselves a great interest rate, 50. Enter years that have passed, we'll say 5. There we go. That's what we would have made. All right, coming down here, these are some more math functions that you can use, or I printed some of these off here for you and grabbed them. You can use an exercise here where you're going to use from and import together and find the square root of 42. So it's a good exercise. I'd recommend pausing and doing each of these exercises to get this hands-on practice. So go ahead and pause. All right, Boolean operators. This is pretty common in most languages, so I won't go too in depth in this. I'll just kind of show you the syntax of it and some examples. We'll probably blast through this pretty quickly. So here I've got this statement. I'm asking if this is true, and then I'm actually putting in the logic right here. So I've got the 3 plus 2 less than 5 minus 7. It's going to check this out and see if this is true or false, and then load this into something called answer, and I'm going to print the answer out. So let's go ahead and run this. Boom. Is it true that 3 plus 2 is less than 5 minus 7? No, it's false. All right, so why? And this is essentially breaking this down and showing why. And we're practicing and doing some callbacks to the first unit with the commas. And, you know, using objects inside of a string with comma here. So yeah, we can run this. See how it plays out. Let's go ahead and move on to the next one. Just a little bit more of the same. Except for these, what I'm doing instead is I'm making it a little bit more dynamic. I mean, I could go even further by making these inputs, but I'm loading 5 and -2 into these identifiers here, and then I'm taking those and I'm saying, okay, I'm actually going to do the math inside of each of these prints to see if they're true or false. So this is a little bit more of a dynamic way to do it. Still not fully dynamic, but a little bit more. The famous and, or, and not. That we can use. So here we're going to load our identifiers up, our objects up. Then we're going to go through and we're going to test this out. We're actually going to be using and, or, and not, or not. So we can use these with these comparisons to make our comparisons a little bit more robust, because obviously we don't want things to be just one-dimensional. There's usually a lot more going on. Actually, that just did one, so we'll just do one at a time here. So we got false, which is what we'd expect. we've got false here, and we've got false. If for some reason you're a little bit lost on Boolean ors and or nots and nots and those types of things, you definitely want to pause and go take a review on that, especially like in SQL. You get into a lot of nesting with these, and you want to be careful when you do nesting. I'm not going to cover that here because we're going over Python, but you know, a good review of deep Boolean logic will go a long way to make sure that you're not bringing back weird data. I've found with these, this is where you get in trouble with these, where everything looks correct, and then 3 months later, all of a sudden, it's not correct. So here's an exercise for you. Go ahead and practice and play around with these. One of the things that I haven't covered that I probably should have covered in the first unit, so I apologize for that, is equals. You may have seen this and go, okay, what's going on here? Or maybe you were able to figure it out. Essentially, if I say A equals 1, what I'm doing is I'm taking 1 and I'm loading it into A. If I say this, I'm saying A does equal 1. It's not going to load 1 into A. So traditionally, you know, if we weren't doing Python, we would be comparing this way. Hey, does A equal 1 is kind of what we're asking here. We're saying, hey, we think A equals 1. In Python, we're saying, no, we're going to load 1 into A. This is that classic kind of logic of going, hey, does A equal 1, or we think A equals 1. This is our not equals. So, but congratulations if you're able to figure that already. I mean, it is in some SQL dialects, and I do believe it is in Postgres, so you're probably just fine. And when you're looking at a list here, this is using the brackets. This defines a list. If it was a tuple, these would be parentheses. We'll do a little bit of a deeper look into this later. But the idea right now is comparison operators and using operators to actually go through, find information, conditional type statements, and in and not in. This is how you would use these to actually go through a list. So if we go like this and run this, we say, hey, is 4 in this list? You know, indeed it is. Take it out, and hey, it's not. So we got an exercise here. This is a dumb exercise. Don't do that one. You've already done it up here. So, you know, hot off the press, I'm always messing around with things. Maybe try practicing around with in and not in. It does look pretty like, hey, I've got it. I can move on. You know, but do you have it? Like, take like a minute again, walk away, come back, go, okay, can I do an in or not in? Okay, so going down here, we're taking a look at variables and math and identifiers. And the idea here is we've got these objects or identifiers, which are also known as variables. These ones are values. You'll hear me say variables sometimes because really these should be dynamic inputs that would bring a value in, which would thus make it a variable. So that's why sometimes you'll hear me say variables loading into an identifier, because I like to distinguish this variable as an identifier and this one as the variable, even though it is a hard-coded value right now. Needless to say, let's move forward. So I'm loading these up, and then I'm using this to load into A, and then I'll probably print A out. I'm creating a little calculator here. I want you to build a IMU calculator. For those of you not familiar with IMU, I kind of spell it out here, but essentially it's the markup of an item, and we want to calculate that and figure out what the calculation is. This exercise, you'll want to save your work on it because we're going to build on it in other exercises. So go ahead and pause the video and work on this one now. All right, so we're going to go into the famous if then, elif, else. It's 3-value logic where you get a return of true, false, or null or unknown essentially. And I'm not going to go into deep on this. There's a lot of training on if then else's. They're one of my favorite little pieces of logic because you can really dig into it and turn any spreadsheet into a task list, essentially a bunch of action items. Buy, sell, hold, right? That's what I think all spreadsheets should really generate to, is what action am I going to take off of this spreadsheet? And herein lies the if then else statements to the rescue if you nest these a lot and really map out somebody's logic of what they do from a spreadsheet. Moving into it though, you'll find that Excel, SQL, Python, R, they all handle the syntax a little bit differently, so I'll talk through the syntax of this. We're going to take 45, load it into days, and we're saying if days is greater than 30 and days is less than 90, then go ahead and print the late fee. I kind of went through that a little bit quickly, so let me go in slow-mo. If then, there's the then. It's this freaking little colon here? Why couldn't they afford just to type in THEN? And why does Excel use just tons of commas? Anyways, when you're reading this, it's if, then. We're going to get to else down here, but this is just an if-then statement. So, hey, if this is all true, then I'm going to go ahead and print late fee. So let's go ahead and run this out. It's true. Hey, we got a late fee. But what happens if we change the day to 50? Let's go ahead and run this. Nothing really comes back because we didn't really we didn't satisfy what the other pieces is. This is where like an Elif would actually come into play, or an else, to handle these other scenarios. Let's go into a little bit more with if then else's, and we're going to take a look at else and the syntax there. So here we've got the pineapple pizza debate. Some people like it on pizza, some people don't. Here we've got a pool of 100 people. 49 liked pineapple on the pizza, 51 don't, and Terry's the one paying. Wild card Terry. All right, so in the first scenario here, we're saying, hey, let's take the people who like pineapple divided by the number of people that we have, multiply that by 100 and see if it's greater than 50. If it is greater than 50, then pineapple does belong on pizza. Else, let's go ahead and print pineapple. We don't have to do the other logic. It's the only thing left over. So let's do pineapple does not belong on pizza. So let's go ahead and run this and see what occurs. Pineapple does not belong on pizza. Yeah, because we have more anti-pineapple people out there in the world. At least in this world, this Python scenario world that I've created. All right, so if we go down to scenario 2, Terry's paying, and well, Terry actually likes pineapple on pizza, so there you go. So we've got pineapple divided by pizza times 100, you know, a little math there, and then the greater than 50, or, and remember, we're playing with some Boolean logic here, or who's paying? Terry's paying, all right? So that's gonna put something into the mix here, so pineapple does belong on pizza, else pineapple does not belong on pizza. So we go ahead and run this one. And away we go. Pineapple does belong on pizza because of Terry. All right, so breaking this down a little bit, we got an if, we have our then, we have an else, and then a then. And, you know, somebody might out there get splitting hairs. This is just how I remember it, right? Else then. So if then, else then. These colons to me are the thens. And essentially when you have a then, it means like then this is going to occur. So just remember these colons mean this is going to occur. This here is essentially a pretty still like one-dimensional if then else statement. We can use elifs to bring in more logic, which is typically needed. And this is still pretty basic, but here we're loading up whether or not we should garden or not based off of some criteria here of weather, day, time, and season. So we go ahead and load these up. Okay, with these loaded, let's go ahead and take a look at this if then else statement down here. We do have something a little bit different. We have an elif. We'll see how this behaves. So with this, we have essentially we're trying to find out if we want to garden or not. And if the weather is equal to sunny and the day is Monday and the time is 5 a.m. and the season also equals winter, then we probably don't want to garden. And you're seeing that the more you add, the better to try to get a good answer. Because, hey, if it's sunny and it's Monday, let's go ahead and garden. But wait a second, it's 5 a.m. and it's winter. And this elif allows us to continue like building off of this logic and say, well, what about if the weather is sunny and the day is Saturday and the time is 10 a.m. and the season is spring? Well, hey, then we're okay to garden. And you can see we can go ahead and really build a lot of elifs down here to, you know, consider any kind of scenario for whether we want to garden or not. Syntax wise, we have an if and we have a then, we have an else, and I like to say else then. So what's going on here with the colon? Well, really this is another if statement. This is a nested if statement, if you will. So we can go into here and say, all right, well, if then. And so it kind of goes along too that you can kind of read it backwards, and there any then is going to probably produce some sort of output. And so essentially before that output you would want to see a then. So before this we have a then right there, and before this we have a then right here. So here's an exercise for you. Essentially we're going to be taking a look at a user age and finding out if they're eligible or ineligible. I'll let you pause and read through this and see if you can put a solution here to make this all work for you. Go ahead and pause now. Okay, welcome back. We're now going to kind of play around with lists a little bit more. I mean, we do have a whole section on dictionaries, tuples, lists. For right now, we're just using this to essentially look at an in, and we're still kind of playing around with if then else's. So we're going to be using this in operator to take a list. We have a list of Washington, Oregon, Idaho abbreviations loaded into an object for Northwest. And we're saying if CA is in the Northwest, then go ahead and print Northwest, else print not Northwest. So this is kind of nice because now we can actually get multiple values inside of one object, have it go through this entire object of list, iterate through, and see, hey, does California actually exist in the Northwest? And no, it does not. So, go ahead and try this. We can put California inside of here and see if it'll actually work, or change this to Washington, see how it behaves. I'll let you play around with that and try that out. All right, so moving down here, we have a kind of an exercise. I forgot to put exercise in here, but if you take this and run through this, what you're gonna find is some kind of funky stuff going on. If we put in WA, it says could not find WA in Northwest region. Well, it definitely is in the Northwest region. Well, let's try it a different way. And if we put in Georgia, it says found GA in region. And probably this should probably say something like Northwest region. So the exercise is, hey, fix the code. Essentially, I forgot to put an exercise here, but that's what this is an exercise for you to get familiar with fixing other people's code. So you can pause the video and work on that now. All right, next up is, I hesitate to say this at all. It gets you into the idea and the concept of looking at unstructured data, trying to find things in it and picking pieces out. And by no stretch of the imagination is this like that. It's just kind of an introduction to bringing strings in and trying to parse through them a little bit. So the idea is we've got a string here that we're loading into an object. And in this, we're saying, hey, if this exists within this object, so it's treating this like a list, then go ahead and print out, this HTTP protocol of 1.1, and we could actually even, bring this in if we wanted to. If the HTTPS is not in the request string, then say it's an unsecured connection. So we'll go ahead and run this. Hey, it's an unsecured connection. So we're getting an actual readout, which is kind of helpful. All right, going into this exercise, you have that IMU calculator that you built. What this is going to do is it's actually going to bring back some suggestions, usually with a initial markup. You're going to have margins that you want to be between. So in this scenario, you want to be between 2 and 14% for your markups that you're doing. And so you're going to evaluate jean prices, shirt prices, shoe prices, and say, hey, are they within these margins? And if they are not within these margins, then bring back markdown, markup, price, or keep the same. And this is the idea of where we want to go with any kind of reporting, is rather than just spitting out more numbers, we want to give a number with an action associated with that number. Now, a customer can use their gut to override that action, but at least we're saying, hey, we've mapped out the logic and this is the rules behind it that give you an action. Go ahead and pause the video and work on this right now. You're going to have a little bit more on this. And by the way, if you're going into this and you start coding it out going, there's got to be a faster way. There is, but just trust me on this and go ahead and work through this exercise. It leads you into something later in the class. Okay, so that brings us to the end of the unit. So we'll go ahead and take a look at the Python skill builder here. I may not bring this up every time, but I at least want to kind of get you going. So in this one, remember, we're going to try to take what we've learned and apply it, and also maybe add a couple of these skills in here. So I'll just put my name in, and we'll put in the unit name, which is math, and the date. Yeah, I didn't put the right format in. And we'll enter the number of times in the loop. We'll say 7. Interpersonal goal, we'll put fluency. You can put whatever you like. And then we'll put some arbitrary numbers in here. We'll just say 4 and 3 on 1. 5. This obviously is random, just kind of jazz. And when you look at this, there's some areas that I can even clean up. I mean, I'm not being really strict here. Here I've got lowercase, and all of a sudden I go to uppercase. You know, I'm jamming through this a little bit. We're getting it done, but maybe I should go back and clean some of this up a little. Anyways, rounding. Got some more of the math ones in here. Oh yeah, that was one thing that I didn't mention was shorthand. It's another way that it's actually called is, you know, we have math compression or shorthand, not to be confused with comprehension, which is a different thing that we will be learning. So loading multiple math functions and identifiers. So we got all this jazz in here. Let's get down here to this last piece. What's the total number of skills? I believe it's 19 at this point. And here we have this kicked out, so we've got our overall rating. Now, you'll notice what I've added is a current level, can teach and mentor with 20% help from some kind of reference. I've, of course, added an if then else in here. It's a pretty straightforward one, but that's the idea, is you want to keep adding what you've learned, not only in your skill builder, but to your program as well. So thanks for tuning in, and I'll see you in the next unit.